Okay, which one again?
3.2 set B.
Alright, so 3.2B, number which one?
26.
Find a 4-digit whole number equal to the cube of the sum of its digits. So, for example, let's do some examples that more than likely won't work, because it would be really weird if I just guessed the answer. So give me somebody, well, you guys can help me. Somebody give me a 4-digit number.
1,000.
1,000. What's the sum of its digits?
1.
You know, Jeff. And then so the sum of its digits, what's the sum of its digits cubed? Let me make sure I read that correctly.
1.
Equal to the cube of the sum of its digits. I like it. So the cube of the sum of its digits. So is this equal to this? No.
No.
So that's the point of this problem is, can you find a 4-digit number? Right, somebody else give me a more kind of diverse 4-digit number.
1350.
One, I love you. Here. 1350. All right, so what's the sum of this guy's digits? 9. And what's 9 cubed? Something. This is exactly. That is exactly right. Now, just be
81 times 9.
729.
That's it.
Are these equal to each other?
How?
Do you see how we're getting closer though?
Mm-hmm.
So I'm going to stop there. So you understand the point of it, right? So
Yes.
I think you didn't quite, which I understand because they word things a little weird. You didn't know what they wanted you to do.
Exactly.
That's what they want you to do. And if you do a couple, you start to realize, kind of see some ideas. You're getting closer, see some ideas of what to try. Is that okay, everybody? That was number, what was it, 26 in 3.2B. Yes.
3.2A, number 12, and then letter C. And set A.
Is this one about Miss Ivanovich?
Yes, I don't know what is it sharing or measurement? I think it's measurement.
Oh,
but
okay,
I can't
okay.
figure that out.
Miss Ivanovich needs to give 3 straws to each student in her class. If she uses 51 straws, how many students does she have in her class? So sharing is when you have a total number of things and you try to figure out,
Counting
yeah, what's a good example? They gave an example.
the height of the one.
Here we go. Yeah, so when you have a certain number of objects and you're trying to divide them amongst groups.
Yeah.
So in this case, this is a little bit weird. The groups would be the students, right? Measurement is when you have a certain number of objects in each group and you're asking how many groups there are. Now, the weird thing about this question is that the groups are the students themselves, right? So it's like a group of 1. Let me make sure, where was this? There it is, I got it. Yeah, so she got 51 straws. She wants to give 3 straws to each group, and then is asking how many groups are there. It would be sharing if she said she's got 51 straws and
Yeah.
she's got so many students.
Yeah.
Yeah, so this is definitely the measurement one.
Yeah, but she didn't say that, so that is
Yeah.
measurement. It would have been a sharing, but since it's measurement, you want to know how many, like,
How many groups there
groups,
are.
like,
And
yeah.
in this case, it's a little weird because the group is 1 student, right? Yeah, okay. You can have a group of 1. Anything else, guys, from that? I'm glad some of you guys
I don't
are
know, that's fun, so
getting into
that's
chapter
fine.
3.
I'm still like on 3.2B.
That's good. It's a good place to be. You're right on track. Because we're just about to get in section 3.3. By the way, everybody understands that you can give me homework before the day of the test, right? You don't have to wait till the day of the test to give me, okay. All right. You guys doing all right? Anybody else tired? I'm tired. Some other people are tired. I understand.
I'm tired.
Don't get too excited. I'm not about to say let's leave. It's too bad.
I didn't fall asleep until 3:30 a.m.
I'm sorry. 3:30. What time do you have to get up?
Around 10.
Oh.
Or like either 10 or 9.
Gotcha.
What's a quotient?
Oh, what's a quotient?
Is it like the thing before the remainder?
Yeah, it's the thing before the remainder.
So
That's a lot, that's hard.
a quotient specifically is just the result of a division problem.
Yeah.
That's it. So what do you call the result of a multiplication problem? Product. So it's just that, it's that level of word for that operation we're doing. Aw, look at that. Thank you. Yeah, so I didn't tell you guys because I wasn't even think about it. I didn't like withhold it from you, but Tuesday was my birthday. It's just, I had a meeting right before our class, and then I came to class. I wasn't even thinking about my birthday, especially because I'm gonna celebrate this weekend, but they did have a surprise party for me, so I trust let's escape. Sorry, so it was great. I'm sorry, so of course I had to play that song. Do you remember?
Oh, yes.
The 21st night. Anybody else have a song about their birthday? No? Okay. Yes.
Would the remainder, do you want the remainder in fraction or just
All right,
remainder?
which problem were we talking?
Sorry, 15, A, on the same section that we're on.
Oh, okay. They want it like big R notation.
Yes.
Yeah. They don't want it as a fraction.
Not yet, they don't.
Not yet. Yeah, we're still in big R notation. All right. Anybody else questions, homework?
I'm still stuck on number 26. As I'm trying big and over and over and over again, but I still can't get what's equal to the whole number, to the 4 digits.
All right.
So I think there's.
Well, you just write down some attempts you've made. Now you got to pay attention to, are you getting closer to an answer or further away? You got to start collecting an idea. See how these are getting much closer than this was, right?
Yeah.
Right? So maybe so what I would do, if I saw this and it was kind of close but not really, I would try to maybe write the same thing but make one number way bigger. Right?
Mm-hmm.
What's 1 plus 3 plus 5 plus 9?
Plus 3 plus 5 plus 9, it's 18.
18, and what's 18 cubed?
18 cubed
I don't know.
is 5,000.
Yeah, way too big, right?
Yeah, way too big.
Okay.
So,
Do you think there's multiple answers to this? Think about it.
Yeah.
What's 1350? Well, yeah, because you got to be careful. In 5103, they would both add to be the same thing, correct? But they wouldn't. They're not the same result. They're all not the same answer. So what I'm trying to tell you is, you might find a situation where it equals all the same digits. Like if this equaled 9351, which it doesn't, then that would have been the answer. I just got these in the wrong order, right? All right, maybe. I don't know if you guys are with me. Because no matter what way you order these numbers, they're going to add to be the same number, of course. Yes? So the whole thing you're hoping is that this answer is this number. Okay. What's your house to say? Yes?
I have a question on number 9 in 3.18.
Oh, good. Okay. All right. So when you look at this, so this is going to happen a few times. I remember I had a teacher. Has anyone ever had a teacher like this? Where if you asked a question in class, the teacher, I'll never forget this person. I was in chemistry. We had just moved. There was a problem. I'm like, I don't understand this process. And she said, just reread the book, Jeff. And I was like, what the shit are you here for? So I always like to remind students, me plus book equals class, right? So there will be times, for example, they reference something called 4-fact families, right? Did you find anything in the reading about 4-fact families?
no.
And I don't know, let's take a look. If it's in the glossary, so let me give you an idea. For example, 4 plus 6 is 10, correct? This leads to 10 minus 4 is 6. This also leads to 10 minus 6 is 4, right? Okay, I like it. So now we just need one more fact to kind of make this a 4-fact family.
6 plus 4 equals 10.
Yeah, you could do like commutativity. Exactly. So it's how do I want to say this? This is exactly the way I showed you how to think about different bases. So, for example, if I had to add, what is 5 base 7 plus 2 base 7? All right, now just give yourself a moment to transition to base 7. What can the answer not be? 7, right? So what is the answer?
7.
Yeah, 1, 0, right? So maybe we would still call it 10, we don't know. Which means 10 base 7 minus 5 base 7 is 2 base 7. All right, that's the kind of thing they're talking about on that problem. Is that cool? Because that leads to, if I ask you to do this addition, does anyone see a really quick way to do that? Without just adding it directly, what would you look for? 10. Shit, yeah, there's a 10, there's a 10, there's a 10, there's 30, done, next, yay. Right? So that's why it's kind of nice to, whatever the base is, we know our 10s, we know to look for them in our base. But 10s in different bases don't mean the same thing that 10 means in our base, yes? So they're just trying to force you to think about what that would look like in a different base. Maybe.
Question.
Yes.
Where did you get 10 base 7 from the
Oh, okay. What is 5 plus 2? 7. But why can't the answer be 7 here? Oh, all right. What's the biggest single digit in base 10?
9.
You with me, right? 9? Which means, and that kind of carries through every base for the same reason. Why is the highest single digit 9 in base 10? Because if I add 1 to 9, that has to go to the next place. Because now I got a whole 10. So base 7, what are the places? What are the places in base 7? 1s, 7s, 49s, right? This is my age. Okay, good. So if I have 7, if I want to have 7, I don't put a 7 here. I got 1 7 and no 1s. In fact, this symbol, no matter what the base, means that you've hit the base. Right? That sounds more musical than it is, but 4 plus 6, you hit the base. You hit 10, so that's 1 0. Right? 5 plus 2, base 7, it's 1 0, because you hit the base. You hit 7, so it's got to be 1 0. You got 1 base and no singles. Maybe. Okay, I like it. All right, so let's get into today's stuff. So today we're going to talk about a little bit more about inequalities. We're going to talk about exponents. We're going to talk about PEMDAS. What the shit is PEMDAS?
Please pardon my dear Aunt Sally.
Please excuse my dumbass son. That's right. Or dear Aunt Sally. Whichever way you like. You guys, anybody remember what that means? Please excuse my whatever you want to say. P is for parentheses. E is for exponent. Okay, okay.
Finally.
Finally? Okay.
Oh, sorry, no, number 26. I found the number.
All right. I will take that as meaning I did something good. Sorry. All right, now, and again, I don't know why. Anyway, we have a place to sit. That's all that matters. So first thing, with inequalities, let's get way deeper, not crazy deeper. So what the hell, if I'm working with whole numbers, can somebody tell me what that means there? If A and B are whole numbers. A is less than B. Now, that's kind of like how you read it. Can somebody give me one interpretation of that? Oh, this is a vague question, man. I love it.
What'd you say?
Give me one interpretation or one example of that idea. What makes a number less than another number?
Closer to the 0 number line.
I like it. Beautiful. There you go. That's what I'm talking about. I love the way you said that. You're like, I don't know if this is what this crazy ass dude wants, but if A is less than B, I'm just gonna kind of throw them in there somewhere. It must be closer to 0 on the number line. I love it. What else? What's another kind of way to think about this? I don't know what you want from me, man. All right, let me kind of lead you down a path. Is this true?
Yes.
Hell yeah. So one quick way to see why that's true, what do you have to add to 2 to make it 5?
3.
Good, right? So this is less than that because it requires something to become this guy. It requires more. That's a slightly different way to think about it, correct? It should immediately make sense. You know, like if a number is less than something else, then that number needs something to become the other dude. That makes sense. Okay, so get ready. I'm going to show you how this guy looks. If A is less than B, same way here, same way. What does that mean must be true? What must be true about A? If A is less than B,
A needs something to.
good. A needs to have something added to become B. Let's call this N. We'll call that N for number, right? Why not? All right, let me stop for a minute. This is kind of basic, but again, this is something you've never really thought about it directly like this, I don't think. Okay, all right. So, let me throw something else at you. What if A is less than B and B is less than C? What do you think else must be true?
A is less than C.
Should, yeah. So this is officially called the transitive property. Anybody ever heard that word before? Transitive? Transitive property. I also call it, well, I affectionately call it the duh property, right? If I'm younger than Jim and Jim is younger than Bob, then I'm frickin' younger than Bob, right? That's basically what it says, right? If Albert is younger than Bob and Bob is younger than Charles, Albert's frickin' younger than Charles. I mean, come on. Right? All right, let's make that entirely too difficult. Here we go. It's something I'm really good at. Yay, Jeff. But, all right, just go with me for a second. Let me erase my little message. So if A is less than B, that means that B is A plus N. Yes, we know that. Where N is just some whole number. Can you write something? No, what do you have to, if I want you to write something like that here, go ahead and try to write it, and then we'll see if somebody gets it right. There's a little something you gotta be careful about. So why can't you do this?
Because B and C could be different than A and N
Yeah.
is the same.
N is the number A needs to become B. Why should it be the same number B needs to become C? I know this is a lot of weird shit and I'm really sorry, but let's do a specific example. 2 is less than 5. Because 2 plus 3 equals 5. 5 is less than 104. Why? Why?
5 plus 99.
Everybody with me? Everybody with us? You might see problems in the homework just like that. What's N over here? What's N? What's N? 3, yes? Everybody with me? Because what is n in this case, in this situation? N is what the number needs to become the bigger number, right? N is 3. Did I put 3 here? No. So let me ask you again. What's wrong with writing that like that? It's assuming that B needs the same number that this needed. So we just call this one, believe it or not, we just call it M. Why not? All right, now let me stop. Now listen, if you are cool with, is everybody really cool with this from this? Is everybody really cool with this? Oh shit, see that's where you gotta ask me a question then. You
I
gotta
zoned
stop
out
me.
for a second, I was so confused when I came back.
No, so don't think about that at all. Don't think about that. This idea right here.
Yes, I know that with the numbers, the variables just confused me.
Oh, why was this 3? Does it always have to be 3?
No.
Was it 3 over there?
No.
No. All this says is there's some number that I add to A to make it equal B. That's all that means. And that's why we have to use a variable, because it depends. It depends on the situation, right? It's not always going to be 3. It's not always going to be 99. Okay. So is everybody truly cool with this sequence right here? Just this. The idea that that captures. So I've already set up n. What is n? It's the number A needs to become B. Is that cool? Do you all agree that if this is true, then B needs a number to become C? Does it have to be the same number A needed? No. Okay, I like it. You guys, I love it. You're all like, yes, Jeff. Take a simple idea like 2 less than 5, make it hard as shit. Thank you, Jeff. I'm sorry.
I got confused because they were written backwards, or not backwards, you could do it like that, but I was just, yeah.
Well, you want it would be
A
better
plus
if I
N equals
put.
B.
Oh yeah, sure, you can do that. So what this really says is A plus something is B.
Yes.
And that says B plus something else is C. Now, could M be? Yes, they could be, but I gotta let it be that they're both different. Okay, now. And watch this. If I take, I don't want to say this. If I take A plus N equals B, right? And if I add M to both sides. All right, let me stop right there. Is everybody cool with that I just defined? Isn't A plus N equal to B? Is this then true also, what I just wrote here? What did I just do on this line? What did I do from here to here? Added the same thing to both sides. That's completely legal, right? If I increase both by the same amount, they're still equal. Okay. But what is B plus M? C. So this says A plus something is C. There's not going to be a huge part of this, by the way. Just kind of try to go with me on this. You're not going to have to do a proof like this yourself. Don't freak out. So what does it mean if B plus something is C? That means that B is less than C, right? If A plus something is B, that means that A is less than B. So if A plus something is C, that means that A must be less than C. Okay. So we took a really stupid, simple idea and we blew it to shit up. Right? But this is, I like this, and I know you guys don't necessarily like it, but this kind of shows you a little bit of what a real proof would look like. You can't just go, oh, that feels about right. I can come up with some examples that kind of make it work. No, this is how you would sort of prove something is true. All right. So that is called the transitive property. You don't have to memorize that. Don't worry. This is what it is, and that's sort of what a proof would look like. Keep myself straight. Blah, 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 blah. Oh, okay. Here comes something kind of interesting. Let's see if you guys remember this. If A is less than B, is AC less than BC always?
What?
If If a number is less than some other number, and you multiply both numbers by the same thing. So for example, is 3 less than 4? Yes. If I double both sides, is it still true? Yes. So in this case, C would be 2, right? If I multiply both sides by the same number, is it necessarily true that the inequality is still true? It still holds? No, it isn't. No. Stay with me now. Stay with me.
Why did you write 2 inequality signs? And,
Sorry. Oh, this is a C.
oh.
I'm sorry. That's what the problem is. All right. Me and writing don't get along. Now, we all should kind of know this, but I'm about to make sure you understand why this is true. You guys remember doing stuff like solving inequalities, and you got somewhere like here?
Yes.
And then you had to do what to both sides to get x by itself? What do you have to do to both sides? Divide by?
-1.
-1. Does anyone remember what had to happen? Do you just get this?
You have to flip the inequality.
You had to flip the inequality. Do you know why you do that? Okay, let's talk about it. Let me show you why you do that. Thank God it's not going to involve n's and m's and shit. Okay, it's going to be very in your face. Here we go. Okay, so why flip the signs sometimes? So let me see. Is -1 less than 2? Yes, that's true. Right? And these are all numbers. There's no freaking variables, so I can see everything. It's all concrete. What if you divide, or even, what if you multiply both sides by -1? Am I allowed to do that? Of course I am. I can multiply both sides of anything by anything, except one thing. We'll talk about it in a minute. So what happens if I multiply both sides by -1? Sorry? Either way, same thing happens. Either way, right? And remember, multiplication is division, so who cares? Yeah, so this becomes a +1. -1 times 2 is -2. Which one's bigger now? The 1 is bigger. What just happened? Yeah, so why do we flip the sign? Cause, right? So when you multiply, stay with me. So everybody, you see what just happened? Right? You can see it. You can just see it. Now think about this. When I multiply by a negative number, doesn't it switch the side of 0 the number's on?
Yes.
Multiply -1 by -1, and all of a sudden it's on this side of 0, correct?
Negative.
So then that means that whatever was bigger is now smaller, whatever was smaller is now bigger. So of course the inequality symbol switches. I love you guys. Some of you guys still look at me like, what? No? You guys don't like that?
Really confusing.
So again, you can't. All right. So which one of these is bigger?
4.
4. Okay. So let's do division this time. Doesn't matter. If I divide both sides by -1, what's 4 divided by -1? -4. What's -2 divided by -1? 2. Which one's bigger now? The 2 is bigger now.
Wait, why are we dividing by -1? Can it be any number?
Could be anything.
Any negative number?
Yeah, what's the point I'm trying to make? If you divide by a negative number,
To see
or
what-
multiply by a negative number,
to
the
see-
inequality has a switch.
Yeah, the inequality switch, and do you see which number is bigger? Like
So,
bigger? Like,
yes.
Like greater or less than?
So we can see the concrete example where we just make the sign the way it has to be, right? But then we develop a theory on this. We develop a thing we can do always. Anytime I'll multiply or divide an inequality by a negative number, the sign flips. And again, let me show you the visual of this. Where's 4 up here? Where's -2 down there? When I divide 4 by -1, it goes here, yes? When I divide -2 by -1, it goes here, yes? So before, 4 was bigger than -2, but now 2 is bigger than -4. Right? So the inequality has to switch. It's because they change what side of 0 they're on. No? Still not. Oh, okay.
I understand that.
Okay, all right. Okay. But in any class you're in, don't just sit there and go, all right, the guy said it was this way or whatever. This woman said this is the way it is. Say, why the hell does that happen? Yes?
If you said why, the reason you said because.
Sorry, say again?
I think the reason why is because you said why, but then you just said because, like.
Totally, yeah, of course. Okay, as a math teacher, it feels so good to have certain situations where I can just go, why is it? Because. I mean, do we all agree with how we had to draw the symbol between the results? Do we all agree?
Yeah.
I divided both sides by -1, something I'm allowed to do. And I get these numbers, and I can just see which one's bigger. That one's bigger. So the sign flipped. So why do we flip the sign when we divide or multiply by a negative? Because that's the way numbers work. No? Okay, maybe? Of course, I understand there's a little more in that because, right? The whole thing about it switches the side of the 0 it's on, all that kind of shit. But also it's just because it's what happens, it's how numbers operate. Now,
I like numbers.
real quick, the other thing, what is a variable? What is a variable?
Another holding a place for a number?
Yes, so a variable is a number I don't know. So how do variables have to act? The same way as numbers do, because that's what they freaking are. Yes? So numbers, when I divide or multiply by negative, the inequality, so variables, same freaking way. If I have a variable inside of an inequality and I multiply or divide by negative, sign's got to switch. X is just a variable, it's just a number I don't know. So they have to act like numbers. Okay, maybe. All right, let me see. So you'll see this in your book. Book? Where'd that come from? If A is less than B and C is greater than 0. Let me say this a different way, because this book is weird. Whole numbers. A, B, C are whole numbers. What does that mean about them?
They're basically not negative.
They're not negative. So then this book will actually say this. And C not 0. Then this is definitely true. What are you doing there? If I multiply both sides by a positive number, they just both get so many times bigger. The bigger one is still bigger. Yes? It's only if I multiply or divide by a negative number, they switch which side of each other they're on. They make jazz hands for whatever reason. Maybe, okay. Love you guys. All right. So now we get into, let's see what you guys remember. I think we've talked a little bit about this before. Before we get into PEMDAS, we're going to talk about exponents, so we can remember how the hell they work. So let me ask, can you guys remind me of this? Before we get into exponents, what does this mean? What is the fundamental definition of multiplication? Repeated. So what does 4x mean? 4x is doing what? Adding. So what does 40x mean?
40x is repeating, or adding.
Yeah. I'm not gonna write them all. All right, now. So, this is sort of the drunk history of math, but it's basically the real history. Somebody had to write x plus x plus x 40 times. And he's like, I ain't doing that shit. Ink is expensive. I got stuff to do, right?
Clothes are.
You with me? I gotta go get some water because it's a long time ago and we don't have plumbing yet. Right, all right.
Spa kits are expensive.
Huh?
Spa kits are expensive and vending
That's
machines.
right, especially back in the 1500s. Now, go to a spa kit from there. All right, now, this person decided, instead of actually writing X 40 times, I'm going to put a 40 in front to mean 40 of these added. Then he spread the word. Said, everybody, do you understand this? And I'm like, oh, that's not a bad idea. Now, stay with me. No, that's kind of silly, right? I don't care. It's roughly what happened. This other dude, at the same time, on the other side of the earth, had to do this 40 times. And he was going to do this. He was going to put a 40 in front and say, everybody, that means times. Go ahead.
I was just asking, who developed that? Like, is there a specific
There's no single person. It was sort of a large group of mathematicians that all kind of together decided the
They
notation.
were originated from like what country?
Oh, this specifically would have been England, yeah.
I guess.
But they had similar ideas in other civilizations in other countries, but that's where it was really formalized.
Yeah.
I like it.
I can't believe I guessed right.
All right, I really want you guys with me. This was an awesome invention, yes?
Yes.
Thank the gods, because if I have 800y, I don't want to write y plus y plus y until I go insane, yes? Do you understand this guy's plight? He's like, shit! He gets the little memo right when he was going to write, he's like, oh, that jackass. Gets this other person, beat him to it. So he's like, all right. How can I make this shorthand way to say this? So he's like, maybe I can put the 40 up here. That just looks weird. Maybe I could put it, that looks like division. Maybe I can do this. No, that's just weird as shit. I really want you with me on this. Think about this person. He's trying to figure out, how do I tell other people I got 40 x's multiplying?
Is this the one where the exponent?
Yes, that's where exponents are. So finally, I settled on this notation. Think about it. Did it have to be there? No. We just know that's what it means because we were taught that's what it means. Why is that what it meant from the beginning? Because somebody put it there and said that's what it was. And the one guy that disagreed, they shot him. That's the way it worked. You don't like it? Okay, 100% approval, moving forward, right?
What year was this again?
Now, that basic definition sets up all the different properties of exponents. I don't know what just happened.
Nothing.
So remind me, what would this mean? Fully technically, what would it mean?
Why
Okay.
But then, yeah.
So then, we all know what this is then.
Oh, y times
Yeah,
8.
but does it make sense completely now? If I have 5 y's connected by multiplication times another 3, now I've got freaking 8 y's connected.
I think I remember something like that while working on the homework in 3.2b. They were actually giving us a hint about that.
Oh, cool. Yeah, they like to kind of get you ready for the next section.
And I've noticed that when you go 5 and 3 in the exponent, it will be 5 plus 3 and it will be 8. So
But do you see why now? Because y5 would be y.
yeah,
Would be y.
because it's repeated addition. So therefore you just combine them and then there you go.
Repeated multiplication.
Or repeated
right?
multiplication.
So coefficients are repeated addition. Coefficients are basically a number times something. That's repeated addition. Exponents are repeated multiplication. And that's all it is. It's just because we were lazy. I don't want to write y 800 times. Right? I just want to write y to the 800 or whatever. That's much better. So here's 5, 3, and 8. Okay, so what about, so there's one. What would this mean then?
Subtraction? You're subtracting.
Yeah. If you multiply and that means add, it makes sense that dividing would have to mean subtraction because there's nice analogies there. Why exactly does that work though?
Division doesn't exist. I don't know.
Oh, I thought you were going, what is division the opposite of?
Subtract, multiplication, sorry.
Yeah, so
That's what
I have 9. Why did I pick 9? All right, everybody just sit there for a minute. I'm almost there. It's almost over. Okay. I have 9 y's connected by multiplication. divided by 3y's. How many y's cancel?
3.
3. So do you see how it's basically, that's why I can capture it with subtraction? Nothing is subtracting. It's just that that is how many y's I'm losing. So subtraction actually leads me to the right number of y's left over. Yes? Maybe? No?
Yeah.
Did I count the y's right?
Yeah, you counted the
1,
y's
2,
right.
3, 4, 5, 6. Okay, thank God. People are looking at it all sideways. So of course, would you ever do this shit right here? Don't do this shit right here, right? This is just for show purposes. I would go straight from here to there. 9 minus 3 is 6. I like it.
Do we get extra credit for trying to show that work in a
No,
quiz?
no, you get actually the opposite extra. Because that's just doing too much, right? So we're better than this shit. We're better than that. This is just for now and showing. So what is this? What the hell would x to the 0 power be?
Undefined.
It's not undefined. So you get some people saying 1. Anybody else say anything else? Good, because it is 1. Why is it 1? Why would that be 1?
Because it's not being multiplied by anything. It's just
I like it. It's almost kind of like connected to a different way I think of it, which I'm going to show second. Let's go back to this property here. What would have to be, if there was 3 x's on the bottom, what would have to, how many x's on the top so that you would end up with a 0 in the power? Think about it.
Wait.
This was, and when there was 9 and 3, I was left with 6, yes?
Yeah.
What do I put up here so that I'm left with none? 3, yes? Then it would be 3 minus 3 is 0. But what the hell is something divided by itself? What's something divided by itself? 1, yes? 7 divided by 7 is 1. Anything divided by itself is 1. Except for 0. 0 divided by 0 is weird as shit. Just a real quick word about that, right? What is 0 divided by something? 0, right? What is something divided by 0? Undefined. So 0 divided by anything is 0. Anything divided by 0 is undefined. So what is 0 divided by 0? It's 0 and undefined at the same time. Shit. So that's something. We're not going to worry about this, right? We're not going to worry about this. But it's called indeterminate. It's worse than undefined, right?
But we're not gonna.
It's something trying to be 2 things at once.
Like, can you give us an example?
I
of
just,
that?
that's it. That's the only example. Right.
Yeah.
I mean, on a whiteboard, because I'm not good visually.
All right. 0 divided by 2 is?
Define.
Is the
0.
0. 0 divided by negative 4 is? 0. 0 divided by almost anything is? 0. All right. What is
You said
1?
almost anything.
No, that's why I put an A. What's 1 divided by 0?
2009.
What's 1? Sorry? 1 divided by 0? Undefined. Negative 412 divided by 0? Undefined. So anything divided by 0 is undefined, and 0 divided by anything is 0. What is 0 divided by 0? It's 0 and undefined. All right, that's all I want to say about that. It's just weird. It's the only number that this rule doesn't work for, and it's called indeterminate. And we're not going to work with this shit directly, so just let it go. And just a little side note, so just to make sure you understand, this doesn't work for everything. It doesn't work for 0. 0 normally is one of the things that screws us up. Negatives and zeros. They're sort of like Jurassic Park thing. They find a way to screw us up. Yes?
I realized that you wrote an A, not a 9. I thought you wrote a 9 for a second, but you said almost anything. Is there anything you can't divide?
This is why I said almost anything, because, yeah. Okay. All right. So the main thing to understand is that x to the 0 is 1 almost always. 0 to the 0 is not defined. It's indeterminate, even worse.
Another question about
Yes.
that. What is 0 divided by I? Or
Oh.
one of those?
0 divided by anything that isn't 0 is 0.
So it's still that.
Still that. Does anyone know what I is?
Imaginary number.
What do I be? Imaginary number, I know it. And we're not going to talk about that right now. I love you guys. I love you. By the way, we are obviously in this class talking higher level shit than you are going to talk with a lot of your students, right? Obviously. And why is that? Because you have to understand more behind the math. If you want to teach this, you have to understand this. Right? I don't know if that makes sense. You want to teach this, you got to understand this. Yes? Is that? You know, like, just say it makes sense so it'll keep going. Okay. What about some other properties here? What would this be? This is really kind of nifty.
We can distribute the 3 to A and B.
Yes. Where's the other place distribution? Could somebody make another one using A, B, and 3 where it would be a different kind of distribution? What's the other kind of distribution? What property? The very first property, the very first thing we use distribution on.
Multiplication. Wait.
When I had like this, let me help you guys out. Right? Isn't this distributive?
Oh, yeah.
All right, now remind me. A coefficient, that's 3 times that. A coefficient is repeated. You could do it. A coefficient, like what does 3x mean? That means x plus x, repeated addition, right? So I want this to make all the sense in the world. Coefficients are based on addition. You guys all understand that now? Coefficients are based on addition. So of course, coefficients are going to play well with addition. 3 of these is 3a's and 3b's. What are exponents based on? What are exponents based on? Exponents are repeated. Exponents are based on multiplication, so they will play well with multiplication. So it distributes exactly the same way for exactly the same reason. If I have 3 ABs, I have 3 A's and 3 B's. Yes? If I have 3 A's and B's, I got 3 A's and 3 B's. Okay, I like it. So what about... Let me think. I think one more thing. I feel like I forgot one somehow. I've been sort of not doing them in order. Blah, 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 blah. Yeah, no, we did that one. Okay, good. I don't think I skipped any. Good. Yay! So here, what about, let's just throw this in here just because. Just because. You guys are going to hate me for this, but you know. What's a negative power mean?
If that's a negative, don't you switch it to top?
How? Well, it's currently on the top. What's underneath it?
Make it a fraction.
Yeah. What's underneath it right now? A 1. Okay, so some of you guys know this rule. If it's to a negative power, you just move it to the other side. Why? Why would you do that? Why not? No, I'm sorry. Look at me. It's okay. Either you forgot or your teacher really didn't tell you. And because I know some teachers just say, this is what you do. And students are like, great. I just wish you guys would go, why? And if they say, I don't know, then you're like, oh, I gotta report your ass. So I'm gonna investigate this the same way we investigated the 0 power. How did we investigate the 0 power? To remind you guys, we developed a division problem that would end up with 0 left, right? And then we can look at this a different way. Oh shit, there you go, 0 power means 1. And before I leave this, what would 4 to the 0 then be? 1. I like it. What would A, B, C to the 0? 1. What would 4 plus A squared divided by B minus C to the 4th power to the 0? 1. Good. I like it. Doesn't matter what this shit is, it's all to the 0 power 1. I like it. So, how are we going to investigate this guy? I want to set up, let me put my x cubed down. It doesn't matter. It doesn't matter what the powers are here. Right? But if I do put a 3 on the bottom, what has to be on the top so the subtraction ends up with -1? 4 would be a positive 1, right?
Integers, not ratios.
No, real quick. If I put a 4 up here, is that correct? No, 4 minus 3 is not that. What minus 3 is negative 1? Okay, let me stop for a minute.
Oh.
Yeah. Did it have to be 3 and 2? No, I'm just investigating this. I'm just coming up with where's one place that negative 1 could have come from. If the bottom is 3, top is 2. If the bottom was 12, top is 11, right? It almost doesn't matter. It doesn't matter what the actual numbers you pick are. What's another way to look at this? The way we did in the first place. Isn't this x times x? Isn't this x times x times x? How many x's cancel? How many are left? Where? There you go. So negative power means flip. Right? That's why it means flip, because that's what the frick happens. Maybe? Another way to look at it is, now here, stay with me. Here's a whole other way to look at this. I think you'll like this way better. That's the way I like better, of course. But here, let me show you another one. And this is going to seem really disconnected at first, which is on brand for me. But how did our number system work again? This is 100. How do I get the next place? Divide by 10. How do I get the next place? Divide by 10. How do I get the next place? Divide by 10. So forth, right? All right. So x squared. If I divide by x, I end up with x to the first power. Yes? Let me write this a little better way. No, it's fine. There we go. Let's do this. Divide by x. X to the first. If I divide by x to the 0, but also x divided by x is 1. If I divide by x again, look at the powers. What are the powers doing? Every time I divide by x, don't I lose an x? I had 2, I got 1, now I got 0, now I've got 2, 1, 0, I lost another one, so now I've got negative 1. Yes?
That's worse.
Which is, what's 1 divided by x? 1 over x. Maybe I was wrong. Maybe you guys don't like that as much. Okay, I try. It's I really want you to understand this. Aren't these fractions back there? Because I keep dividing by 10. So if I keep dividing by x, don't I eventually get fractions of x, right? So this, do you guys know that this is 10 to the negative 1 now, right? So x to the negative 1 is 1 over x. I just make by fractions. I'm going to keep dividing. No, you guys don't like it. Okay. All right, those are the two main ways to look at it. So here, what would this be? One over n. Crazy. What do you think this would be? Just a little more specific.
7 over 4?
7 over 4, yeah. That's what negative power means. What's the negative power mean? Flip.
Flip.
Negative power, 4-letter word starts with F. You can say mixed company.
I can't believe I guessed that right.
Nice. Well, you knew the idea was flip. So then you said, oh, if I flip that thing, it's what I get. 11. No. What about this?
Oh.
Oh. No, just keep doing it. What's the negative power mean?
Flip.
Flip. Where is it now? Bottom. Where's it going to end up?
Top.
Top. All right, here's a really
How
silly
does
way
that
to
work?
learn.
How does that work?
I'm sorry?
How did you end up with A? Oh.
All right.
Let
Let me. You ready? All right. Here's the crazy way to do it, but let me show you. What is a to the negative 1? Isn't it 1 over a? Doesn't that look great? Stay with me. Isn't this 1 divided by 1 over a? Do you guys agree with me? Isn't that what that says? Does anyone like that? No, just go with me. How do you divide fractions? You multiply by the... What's that 1 times a? Freaking a. Freaking a. So what's the shortcut? Why were you all cool with this and not cool with that? I don't understand. Where is this m at the moment? Is it top or bottom, this m?
Top.
It's on the top. Doesn't like it up there, so it's going to go down. Where's his A? On the bottom. It doesn't like it down there, so where's it gonna go? Up freaking top. That's all a negative. What is happening? That was interesting. All right, let me see. All right, totally lost my train of thought. So all a negative power means is flip. If it's on the bottom, it wants to be up. If it's on the top, it wants to be down. So look at this again. That means flip. 4 doesn't like it up there, wants to go down. 7 also wants to go up. What's flipping? Both of these are flipping. Bam, right? That's all a negative power means is flip. If it's on the bottom, it goes up. If it's on the top, it goes down. Yes? Okay, maybe. So, what about this? Why are you going to write an example now, Jeff? You haven't. What is 2b to the negative 1? No. I'm sorry. You're all like, well, let me give it a try. No. What's being raised to a negative power?
Just B.
Just
Unless
B.
it was
What is 2 being raised to?
Nothing.
Understood to be 1. So what's the only thing that doesn't like where it is?
B.
The B. So it's going to go down. All right, I'm sorry. The whole negative power thing was actually just me throwing stuff in. But that makes a complete picture of exponents. Okay, all right, like it. So again, exponents are just repeated multiplication. So let me ask you this. Let's come back, let's get away from the negative stuff. Remind me again what this is? This kind of thing here?
A squared plus, or A squared, B squared.
A squared, B squared. What about this?
A squared plus B.
No.
Or,
A plus B squared.
A squared plus B squared plus A squared plus B squared?
No.
there's not two.
So real quick, this is not going to be anywhere near as easy as this. Why is this one easy? What's the operation inside? And what are exponents based on? Multiplication. Right? Keep that in mind. Exponents?
B plus B.
No. Does anyone know the real way to do this? You'd have to write A plus B twice, and you have to FOIL.
Oh, gross.
Yeah, I know. But that's, foiling is gross because it's a way around order operations. You can rewrite the problem to figure out a way. Because what would order operations say? Do the inside first. Well, what the hell is A plus B? Do you guys know? A plus B is purple. I don't know. Right? Oh, okay. Sounds good. A plus B is squared. All right. Really want this to make sense, though. Please let this make sense. Exponents are based on multiplication. If they're acting on something that is multiplying, that should be easy because it's exactly what it's based on. If it's acting on some plus minus whatever it's not based on, that's going to be hard because they don't play well together. That's not based on addition. But if it was this, easy as shit, right? Because coefficients are based on addition, so this must be easy. They are based on the same thing. Bam! All right, Jeff, calm down.
I think the last time I did this was middle school. So.
I know.
Maybe algebra, math 110,
Okay, sure. Now,
maybe.
so that is exponents. Last thing for today is PEMDAS. All right. And what really, really makes me sad about this is that I know for sure there are teachers that teach it wrong, which leads to all those damn Facebook posts about, what's the answer to this? It's this. Oh, come on. Sorry. Hopefully some of you guys are just not on Facebook. See,
My mom
I need to get off of there, but I can't, because then my mom would be like, don't delete Facebook.
My mom makes me solve problems like that for her, so she can give me the answer.
Oh, I see. Can you real quick, okay, what? And do you tell her the wrong answer and let her kind of like, no, okay. Anyway, sorry, if you don't know, like every week, there's a post on Facebook with a problem like 4 times 4 divided by 4 times 4.
Yep, that's on Instagram too.
Yeah. All right. So this is what kills me. So let's come back to this in a minute. Let's put a pin in this. What does PEMDAS stand for again? Don't tell me, please. P is parentheses.
Exponents, multiplication, division, addition, subtraction.
I love it. And there. It could have been. All right. So I don't like writing it like this. It actually could have been this. It could have been this all day long. It could have been that. Which one's easier to say? This is PEMDAS. Can somebody pronounce this for me?
PEMDAS.
You sound like you're drunk. Let's just try to use PEMDAS, officer. PEMDAS. Now I want you. Does anyone understand what the hell I'm talking about? Why it could have been written like this instead? Why?
Subtraction, or sorry. Something about the order operations are the same or they don't exist.
Oh, I see. I like it. Yeah, sort of. Yeah.
It doesn't matter what, like, it has to be like in horizontal, whatever comes first is what you do first.
Yes,
Like
so-
either multiplication or division or subtraction.
Here's the correct way to write this. Parentheses first for damn sure. Anything inside parentheses gets immediate priority, right? In fact, you know, do you remember from algebra, where'd you almost always start? Equations, everything, you started in the parentheses, didn't you? Because that's on the freaking top. Then exponents, definitely exponents next. Then, either one of these, as they come, nobody gets priority. I have heard teachers teach that multiplication comes first. I just don't know. I'm like, why? Get out of this profession. Okay. And then, at the ass end of PEMDAS is addition, subtraction. All right, so please excuse my dumbass son. I had a class, did I tell you this? I had a class that came up with this on their own. I didn't come up with this and tell them, or if you think I'm an asshole, you can think I did. Please excuse my deficient algebra skills. Right? They came up with that on their own. I was like, okay, whatever works. So, here. We're not going to try that problem out yet. What would this be then? You do it, John. I like. Look at that. That's a monster little thing. All right. So the very first thing you do. All right, sorry. Very first thing you do is write it down. I'm sorry.
Please excuse my dear Aunt Sally, or please excuse my dear dumbass son.
Dumbass son, that's right.
Please excuse my deficient algebra skills because I don't have it.
Please excuse my dumb ass.
All right, you can make your own up at your own leisure. What's the very first thing I do?
Parentheses.
Parentheses. Because what am I squaring? Here's the whole idea. I don't know what I'm squaring yet, so I better freaking.
You're squaring 2.
Good. I'm squaring 2. Now I know what I'm squaring.
4.
Now, one big mistake people make is they'll make this 14. But then you're doing multiplication first, which you're not supposed to. You're supposed to do it as it comes. Yes, and I'm going to talk more about that in a minute. So leave that as it is. What's the next thing you do?
Exponents.
Exponents. So 2 squared is? Holy shit. Well, from the very beginning, I should have said this. What's the very last thing you're going to do?
Addition, subtraction.
So I'm going to do the subtraction last because it's at the ass end of index, right? That joke is mostly just for me, but I still like it. You don't have to. Don't worry. In fact, I appreciate it. You don't. This little ant. All right. Then I do 4 divided by 2.
2.
2.
And then you get 14, and then you get 4 minus 14, and then you get 10. Negative 10, my bad.
That's all right. If I had $4 and I owe you 14, I can give you my 4. I still owe you 10. So you can always think of addition, subtraction in terms of money. What?
What
Sorry?
happened between 4 divided by 2 and times 7 and the next one?
What is
There
4 divided by 2?
2. Oh.
And then 2 times 7? 14? Because we knew we were going to do the subtraction at the end because it's at the end. Right? So, why is it not correct to make this 14?
Because division comes first.
In this, well, all right, and there's a different way to look at it than just a rule, right?
From the left to right.
Yeah, exactly. What's the only number that is being divided? 2. So let's just look at this part. Let me see. Well, let's look at the whole damn thing. So let's look at it right here. Yeah, let's look at right here. Let's pull this part out. I'm gonna pull this part over here. Okay. How can I rewrite 4 divided by 2? It's another way to write that.
1/2. Oh.
4, yeah, I'm with, all right, 4 over 2, right? So it'd be 4 minus 4 over 2 times 7. Now, if you made this 14, how the hell did you get that 7 to come down there, right? So I really want this to make, just make common sense. It isn't something you have to necessarily memorize. It just makes sense. The only number that's on the bottom in this whole freaking thing is 2. That's the only number that's on the bottom. It's the only number being divided. Maybe. And then here you can see this is 2, and then we just keep going the same way we did. Maybe. So, does somebody have an answer to this?
Can you do multiplication and division at the same time, but it would just be, in this case, would it just be left to right?
Yes, that's the way you have to do it. Basically, well, let's see. Does anyone have an answer?
16.
16 is the right answer. If anyone got 1, not quite right. So 4 times 4 is 16. 16 divided by 4 is 4. 4 times 4 is 16. And again, if you rewrote this, wouldn't this be 4 times 4 over 4 times 4? What's that? Isn't that 1? So then you have 4 times 4 is 16. It's another way to do it. Right? Rewrite the division as a fraction, and that's a whole other way to do it. Maybe? Is that all right with you guys? Maybe? All right. Okay. So here's, well, let me see. That's pretty good. Here's one example that shows why I have students who always do division last, which drives me a little insane. Which one is this, Jeff? There you go. If I had this problem,
Division.
what is the last thing I would do in this problem?
I think division.
Division, yes. Now, I think students do a few of these and then they just get it in their head, they make their own rule, division always last. Which is obviously not true because PEMDAS does not end with a D, right? It's in the middle. So if I wanted to write this, I'm not even doing this problem yet, if I wanted to write this in a straight line, why is this incorrect? Why is that incorrect? That is not the same thing at all. Those are totally different things.
Because then you wouldn't divide last with that.
In this problem, what was on top? Can you tell if I just show you this? You can't tell. What is on top? Isn't this on top? Oh, it's understood parentheses. This is what's so evil. When you have a big ass division bar, there are hidden, do I have to draw these parentheses in for you to understand that? No, the big ass division bar distinguishes top and bottom. But if I put it in one big ass line, I've got to put the parentheses in to remember what the top was and what the bottom was. Now it's really obvious. What's the last operation I do? Division, because it's the only thing that's not in a parentheses set, right? Both of these get elevated to the top. They get done first. This is the one that's done last. This is my hopeful tai chi.
How do you fingers cross like that without pain?
Like that. No pain. That's how it's. So, you normally wouldn't write it like that. How would you do this problem?
Do you multiply first? Or 2 times 3?
Yeah, you got it. So 5 minus 6. And what would happen on the bottom?
3 squared, or
4
9, 4 minus 9.
I like it. 4 minus 9. And then
Negative 1 over negative 5.
5.
no. I don't see any negative powers.
Positive, 1/5.
Yeah, it's just positive one. The negatives cancel, that's all right. It's only negative power. Power that can make something flip. I like it. Now, last thing for today, and then we're going to get out early. Is that all right? Oh man, if I wanted you guys to really hate me, I can then go, no, I decided no.
No, it's not that I hate you, I'm just hungry.
No, if I did say, we're gonna stay.
I don't hate you, I'm just hungry. Me eating my apples back here.
Alright, so last thing. Let me see, I got a little example, let's try. So what if you had a student that said, okay, so this, and of course we still have this symbol for us because you're gonna have that symbol with elementary students, right? This is this. So they totally get that. The student totally understands that idea, right? Of course,
Wait, the X is the multiplication, right, not
That's
the
right.
variable,
That's
okay.
right. So at this level, we sort of let go of the X because now it means variable. But up to 5th grade or whatever, it doesn't mean variable yet, right? So they're still gonna use times, okay. So everybody cool with that? What property is that, of course? What property? Distributive. So what if they say, oh, if that's true, then that means that this is true. Is that so? Is that true?
Wait,
What?
I'm seeing X's and automatically thinking variables.
I know, you're gonna have to let go of that because you're gonna be teaching with X many times.
I'm thinking
Right?
I can do that,
there's
but I
like
don't
lots
think
and
I have
lots
to do
of
the parentheses,
They're all times. That's
Yeah.
that's
Alright,
12
so get
times
over that.
2
Here, let me rewrite the problem
Six.
without the X symbol, okay?
times.
Now
yeah,
rewrite the
times
problem.
8. So it's
I kinda like that you guys don't like that because of the X, but again, remember, you gotta get over that shit because you're gonna be, some of you, is
I guess we did de-learn today, or unlearn.
that better?
What I
Is that better?
it's a
Oh.
plus.
That's better.
It's a plus. I thought that was a multiplication because I just already got the answer. Or no wait. What?
So how do I write this? This is a little weird now. Alright, see, it's hard to write this because it's wrong.
Why are there so many parentheses?
I kinda got the
What do the
answer.
parentheses mean here?
Multiplication.
Multiplication.
Why is the forest standing alone?
What do you mean?
Multiply.
How about this? How about this?
That's better.
Alright, now, can anybody tell me, first off, do you agree with me that this is wrong? And that's normally a good bet, right? It's like that guy in front of the room, he probably knows what he's talking about. I could be momentarily insane though, so I could be, or more long-term insane, I don't know. There's a really simple reason this is not correct. When I get students who do this all the time without really thinking about it, drives me a little crazy, but I kind of understand why they would think this. But again, what does this mean? What does the coefficient mean?
Addition.
Repeated addition. That's why this plus is here. That is why this plus is here, right? So what, again, there's a times in the middle that doesn't make any sense. Right? So this, of course, what's the right way to do this?
3 times 4 times 3 times 4.
Yeah.
Right?
No.
Oh.
3 times 4 plus 3 times 4, right?
Yes.
3 times 4 plus 3 times 4, because you got 2 3 times 4s. Right? The answer to this should be 24, correct?
Yes.
Not 48, right? You with me? I love you guys.
I got 24.
What's happening right now? Yeah.
I got
The
24.
correct answer to this is definitely 24, because
But-
you would normally just do 3 times 4 is 12 times 2, right?
Yeah, that's what I got, but on the other side, I got 48.
Which shows you that this can't be true.
Yeah.
But again, what's another way you can explain this? How many 2's are in this expression? 1.
Two.
Isn't there, how many 2's
One.
are in this expression?
1,
Thank you. How many 2's are in this expression?
2.
So then you can say, where did you get the extra 2 from? It doesn't matter. And then they're gonna come at you with, well, then where do you get your extra 2 from? Right? And then you'd have to remind them how this got, I did show you where distributive property came from last time, right? Okay, we can kind of show them that. But it basically is because this means repeated addition. So it can't suddenly lead to repeated multiplication. That doesn't make any sense. Okay. So that's something that comes up a lot, It's not understanding when the distributive property really works. All right, and that's it. I'll let you guys out here. Oh, please. Yeah. I take that as an insult because you're like, oh, thank you, Jeff. We don't